The largest iceberg, A23a, had been stacked on the continental shelf for about 34 years from 1986 to July 3, 2020. The size of A23a is about 90 by 75 kilometers with an area of 4,200 square kilometers with a thickness of 400 meters in the initial stage. The visible infrared imaging radiometer suites on Suomi NPP, NOAA, 20 and 21 had provided the view of A23a in time series. The Level 0 data of visible infrared imaging radiometer suites were provided by NOAA Comprehensive Large Array Data Stewardship System. This is a track of A23a from July 4, 2020 to February 20, 2025. In the first stage, A23a was moved from the continental shelf to the Weddell Sea by tidal wave. In the next stage, the western boundary current called the Weddell Sea Gyre, which is the water body from the surface to 3,000 meter, pushed A23a along the Antarctic Peninsula. In the third stage, the jet passes through the ridge between the Weddell Sea and Scotia Sea, pushed A23a to the Scotia Sea. In the fourth stage, the Antarctic circumpolar current pushed A23a toward the South Georgia Island. On the Scotia Sea, the meandering or the vortex associated with the Antarctic circumpolar current determined the drifting route of A23. The Antarctic circumpolar current, of which the water body scaled from the surface to 3,000 meters, exhibits the meandering or vortex because of the bottom-affected instability of baroclinic waves. In this report, the final approach of A23a to South Georgia Island is introduced. This is the track of A23a close to South Georgia Island. The sea ice, snow, and snow crystals in clouds are displayed in yellow with a combination of spectrum bands of the visible infrared imaging radiometer suites. And water particles in clouds are displayed in white. A23a is drifting with a counterclockwise rotation because of its huge size to be pushed by the sea water. This is the track of A23a on the topography map from December 14, 2024 to January 22, 2025. It is difficult to estimate the route of Antarctic circumpolar current, but it is considered that the Antarctic circumpolar current runs to east between South Georgia Island and South Sandwich Islands with a water mass from the surface to 3,000 meters. But it seems like A23a will hit the shelf 200 to 300 meters depth along southern Georgia Island shortly. The visible infrared imaging radiometer suites has a capability to observe a sea surface temperature and chlorophyll A concentration to understand the drifting of A23a, although a possibility of observation is small because of cloud coverage. This is a sea surface temperature on January 7, 2025. The sea surface temperature from -2 to 10 Celsius degrees is colored from dark blue to dark red. It is possible to observe a cold water body on the north of A23a. Next is a chlorophyll A concentration on January 7, 2025. The chlorophyll A concentration from 0.01 to 0.2 milligrams per cubic meter is colored from dark blue to dark red. It is possible to find a slightly higher chlorophyll A concentration, which is a higher productive water, on the cold water body observed by the sea surface temperature. The higher productive water colored in orange to dark red on the west of South Georgia Island suggests a higher concentration of zooplankton and a big amount of krills and small fishes. A combination of sea surface temperature and chlorophyll A suggests a meandering of Antarctic circumpolar current as indicated by the blue line, and also suggests that A23a may drift in this direction. This is a sea surface temperature on February 20, 2025. It is possible to observe A23a is shifting to the north along the cold water body. The boundary of the cold water body is located along the shelf of South Georgia Island and continues to the southeast, which suggests the cold water body on the surface is a part of Antarctic circumpolar current. According to the chlorophyll A concentration, A23a is drifting to the north with exhibiting a higher chlorophyll A concentration around itself. There is a higher productive water on the northwest of South Georgia Island as well as the higher productive water on January 7, 2025. These higher chlorophyll A concentration could be a phenomenon known as a fall bloom of phytoplankton. The clockwise cold water current is indicated by the blue line, and there are two warmer eddies counterclockwise with a higher chlorophyll A concentration, indicated by red lines. The estimated speed of A23a on February 20, 2025 was 21 kilometers per day. It was slightly difficult to explain the drifting of A23a because of clouds in this region on February 22, 2025. The A23 is drifting to the north with a speed of 25 kilometers per day.